Here we will try to understand why in a convex lens light rays are converging at one focal point when they are falling parallel to the principal axis. So when we talk about the convex lens or a converging lens, the light ray, if I say call it light ray 1, you will find to meet at a focus it is bending a lot compared to light ray 2, whose bending is little lesser, so that they all can converge at a point F. If we see the lower part of the lens, these rays are bending upward. The ray 3, it is bending upward and bending more compared to the ray 4. So why it is happening? For that, we can see a convex lens as number of prisms stacked together. To understand why different light rays are undergoing different degree of bending, we will see them as different small prisms stacked one over another. In the upper part of the lens, the base of all the prism is towards the principal axis, where they are opposite in the lower part of the prism. Now, if we take the upper part, the uppermost prism, here, if we take the ray number 1, which is passing through the topmost, and the ray number 4, which is passing through the lowermost prism. To understand why different rays are going through different kind of refraction, why they are bending at a different degree, we will see the topmost prism and the bottommost prism of the given lens. And if we compare this with the next prism, which is something like this here, we will find the angle of the prism A is largest for the topmost and the bottommost prism. If we extend the next one, we will find the next prism will be somewhat like that. So the angle of prism for the next prism is smaller compared to the topmost one. And as we go towards the principal axis, the same thing will keep happening. And we know the angle of prism affects the angle of deviation of the light ray. And because of the angle of the prism being largest for the topmost and the bottommost prism, the angle of deviation is maximum there. So this will be the angle of deviation. So angle of deviation is maximum for the topmost prism, whereas you can see here the angle of deviation is little smaller compared to that, and so on towards the principal axis. The reverse phenomena will take place from the bottom part. This happens because this is a peculiar behavior of a prism that when the light falls on its lateral surface, it bends inward due to refraction, and then it bends further down towards the base as it comes out. So in general, we can say a prism will refract a light ray towards the base. And the relationship between the angle of the prism and angle of deviation is bending them all in a different angle so that all are focusing in one point, that is a focal point. Similar will be the case of concave lens. Here we will see them to be number of stacked up prisms, but in opposite fashion. And with the similar concept of refraction of light through the prism, the parallel ray of light will undergo different kind of bending. They all will bend in a different angle. Angle of deviation will be different, will depend upon the angle of the prism, and as a result they all will diverge out because they all are moving towards the base, whereas these prism has got the base on the upper side here. So as a result, the parallel rays which are falling on one side of the concave lens will diverge out. They will spread out. The outermost rays will suffer more deviation and they will diverge the maximum, and the ray which is passing through the principal axis will move unaffected.